Hello, welcome to Geotechnical Engineering Part 1, Particle Size Analysis. Today we'll be discussing about size and nomenclature of soil particle, coarse grain and fine grain soil, sieve analysis and sedimentation analysis. So natural soil, we all know, is a mixture of various size of particle. To determine the particle size, a square hole sieve is being used and which is expressed in single diameter. Size and nomenclature according to the Bureau of Indian Standard IS 1498 1970. Very coarse, coarser and fine soils are being described. Boulder size greater than 300 mm, cobble size 80 to 300 mm, gravel 20 to 80 mm coarser and 4.75 to 20 mm finer. In sand 2 to 4.75 mm coarser, 0.425 to 2 mm medium and 0.075 to 0.425 mm finer. And now finer soil, we have silt and clay. Silt of size 0.002 to 0.075 mm and clay less than 0.002 mm. So here gravel is denoted by G, sand is denoted by S, silt is denoted by M and clay is denoted by C. Now what is the difference between coarse grain and fine grain soil? Coarse grain, which is frequently and identified based on the particle size, and fine grain based on plasticity. Individual particles are visible in coarse grain and in fine grain may not be visible by naked eyes. Coarse grain is divided into two categories, that is gravel and sand. In fine grain we have two categories, that is silt and clay. Shape of gravel vary from round to angular and silt tend to be spherical shape and clay may be flaky shape. So here particle size will be larger than 4.75 mm termed as gravel and 4.75 mm to 75 micron is sand. Here in fine grain soil particle size may be 75 micron to 2 micron, which is said to be the silt, and less than 2 micron we say it as a clay. So coarser grain soil have 50% or less material passing through 200 sieve. Finer particles of soil having 50% of more material passing through 200 sieve. Here using mechanical analysis we can determine the size of various particles which may be coarser or finer. Sieve analysis is a dry analysis process where particle size greater than 75 micron is being analyzed, which may be into the form of two types, coarser sieve analysis and finer sieve analysis. Of 75 4.75 mm and greater, which is identified by coarse sieve, and less than 4.75 mm identified by the fine sieves. Here you can see the sum of set of coarse sieve and fine sieve. Similarly, sedimentation analysis is a wet analysis process for less than 75 micron particle size, which may be identified by the hydrometer and pipette method. So here you can see the sieve analysis. to determine the particle size of soil. Here, finer sieve is at the bottom, and likewise coarser sieve is at the top. Procedure to find out the particle size using the sieve analysis. First of all, weight a dry soil sample taking at least 500 gram. Record the weight of sieve and pan that will be utilized during the analysis. Clean up all the sieves before the test. Assemble the sieve in ascending order. Larger sieve will be at the top. Place the soil sample into the top sieve. Place the lid or a cap and place this whole set of sieve on a mechanical shaker for 10 minutes. Remove the sieve shaker and measure each retained particle on the sieve and pan placed at the bottom. Here is the observation table where we'll be recording all the retained soil, percentage retained, cumulative retained, and finer mass. So by filling the observation table, we'll be getting the percentage of particle size. Now for particle size less than 75 micron, we need to have a sedimentation analysis, which is a wet. And the sedimentation analysis can be done either by hydrometer and or pipette. So here, in order to analyze the sedimentation analysis, some of the assumptions are particle size may be perfect sphere, liquid throughout the particle fall must be of indefinite extent, the particle reaches constant terminal velocity with a few seconds and it maintained indefinitely. So sedimentation analysis based on Stokes law, which is velocity of a particle undergoing settlement within the indefinite or infinite medium, which is depend upon size, shape, and mass of particle, which is said to be the terminal velocity. Here Vs is equal to g minus 1 small g d square by 18 mu. Capital G is the specific gravity, small g is the gravity, d square diameter of the particle, mu is the viscosity of a fluid. So based on the assumption, there are some of the limitations. Here particle size are said to be the spherical, but finer particles may be Franke or needle shape. Specific gravity of solids for different particle is different. We use average value. So this is also one of the limitation. Stokes law is applicable when the fall of particle is in the liquid, which has infinity extent. That is, no boundary is present. But our suspension in the jar and its wall affect the results to some extent, as falling particle may collide with the wall. So this is also one of the limitations. We have also assumed that there is no interference on the movement of particle by other surrounding particles, which is also a limitation for us. Sedimentation analysis cannot be used for particle size larger than 0.2 mm because they may cause to generate turbulent condition. So this is also a limitation. Sedimentation analysis is also not applicable for particle size smaller than 0.2 micron. So these all are some of the limitations based on the Stokes law. Thank you for listening. Thank you.